Also tonight, a tsunami threat has now passed for the Pacific Northwest after a 7.0 magnitude quake hit off California's northern coast today. The quake hit shortly before noon. It was centered off the coast of Eureka. It briefly triggered a tsunami warning for millions of people along the coast from southern Oregon to San Francisco.
Stay opaque right now, because what just moved beneath Northern California isn't just another earthquake. It could be the warning sign of something far bigger, something scientists are only now beginning to understand. 1 minute ago, the Earth shifted, a low rumble, a quick vibration, the kind people barely react to anymore. Phones buzzed, alerts flashed, and within seconds, life went on. To the public, it was forgettable, routine, expected. But deep underground, it wasn't routine at all, because hidden beneath that brief moment of shaking was a signal, a pattern so unusual that it forced scientists to stop, rewind, and ask one question: what did we just miss? For decades, California has been defined by one, Yuma the San Andreas Fault. It's the giant crack everyone talks about, the line that divides not just land, but fear itself. Entire documentaries, predictions, and emergency plans revolve around it. It's been labeled the big one, waiting to happen. But here's the part no one really talks about. The San Andreas is not alone, not even close. Beneath California lies a deep, tangled network of faults like veins running through the earth. Some are mapped, some are partially understood, and many are completely hidden. These faults don't exist in isolation. They twist, intersect, sway, share, and influence each other in ways we're only beginning to uncover. And sometimes one small movement is all it takes to reveal something massive. That's exactly what happened here. Moments after the quake, seismic monitoring stations across the region began collecting data. At first, everything seemed normal. But then analysts noticed something strange. The seismic waves didn't behave the way they should. Instead of traveling cleanly along known fault lines, they bent, slowed down, scattered in unexpected directions. It was subtle but undeniable, almost as if the waves had encountered something deep underground, something solid, massive, and completely unaccounted for. That's when everything changed. Because in seismology, when waves behave differently, it usually means one thing. There's something there, something we didn't know existed. Within hours, researchers launched an emergency level analysis. Using advanced 3D seismic imaging, they began mapping the underground region in extreme detail. This technology doesn't just look at the surface, it penetrates deep into the earth, revealing structures hidden for millions of years. Layer by layer, the picture became clearer. Known faults appeared, rock formations aligned, sediment layers told their story, and then something unexpected emerged from the data: a massive fault line, stretching across miles, deep beneath Northern California, hidden, unmapped, silent eye until now, a mega fault. The scale of it was shocking. This wasn't a minor crack or a localized fracture. This was a major geological structure, large enough to rival some of the most dangerous faults in the world. And the most unsettling part, it had been there the entire time for millions of years. This fault existed beneath layers of rock and time. It formed through tectonic movement, shifted during ancient earthquakes, and then slowly disappeared from detection. Buried, forgotten, invisible to older technology. Until this moment, as the data continued to pour in, scientists realized this wasn't just a discovery, it was a breakthrough. But with that breakthrough came serious questions. Could this fault produce a major earthquake? Could it interact with the San Andreas? Could multiple faults rupture together, creating something far more destructive than expected? At first, the possibilities felt overwhelming. The idea of a hidden mega fault beneath populated regions sounds like a nightmare scenario. But science doesn't panic. It investigates, Back in labs across the country, geophysicists began analyzing every detail: wave patterns, rock density, stress accumulation, historical seismic activity. They ran simulations, compared data, and searched for answers. And slowly, a clearer picture began to form. This fault is different. It doesn't behave like the San Andreas. It doesn't move in a straight, predictable line. Instead, it's irregular, complex. Some sections are locked tightly, building pressure over long periods. Other sections move slowly, releasing energy in smaller, controlled shifts. This means it doesn't act as one giant ticking bomb. It acts as part of something bigger, a system, a network, a living structure beneath the Earth's crust where pressure is constantly shifting, transferring, balancing between multiple faults. And that realization changes everything, because for years, earthquake science focused on individual faults. One fault builds stress, then releases it in a major rupture. Simple, but reality. Reality is connected. This discovery suggests that earthquakes don't always start where we expect. Stress can move across faults, jumping from one structure to another. A shift in one area can trigger movement somewhere else, sometimes miles away. It's not one fault controlling the outcome. It's the interaction between many. And suddenly, predicting earthquakes becomes far more complex. As researchers dug deeper, they found something even more fascinating. Evidence suggests this hidden fault may have been active in the past, quietly influencing earthquakes that were previously attributed to other systems. In other words, it's been part of the story all along. We just didn't know it. And this isn't just happening in California. Around the world, similar discoveries are reshaping our understanding of Earth's behavior. In Japan, earthquakes have been observed jumping between interconnected faults. In Turkey, massive quakes have revealed complex networks beneath the surface. In South America, entire regions shift due to deep, linked systems. The pattern is becoming clear. The Earth doesn't operate in isolation. It operates as a connected system, and we're only just beginning to see it. So, what does this mean for us? Here's the truth. This discovery doesn't mean a catastrophic earthquake is about to happen tomorrow. There's no countdown clock suddenly speeding up, but it does mean something critical. We've been looking at the problem too simply, and now we're starting to see the full picture. With this new understanding, scientists can improve how they assess risk. Engineers can design buildings that handle more complex shaking patterns. Cities can update emergency plans based on interconnected fault behavior. Knowledge changes preparation. Preparation saves lives. But even with all this progress, one thing remains certain. We still don't know everything. Not even close. Because beneath our feet lies a world we've barely explored. A dynamic, shifting system that operates on timescales far beyond human life. Every tremor is a message. Every quake is a clue, and this one just revealed something massive. This wasn't the strongest earthquake. It wasn't the most destructive, but it may be one of the most important discoveries in recent seismic history, because it exposed a hidden structure that forces scientists to rethink everything from prediction models to risk assessment to how we understand the planet itself. The next San Andreas isn't replacing the old one. It's expanding the story, a reminder that the ground beneath us isn't stable. It's alive, moving, evolving, and still full of secrets waiting to be uncovered. So the next time the Earth shakes even slightly, don't ignore it. Because it might not just be an earthquake. It might be the planet revealing another piece of the puzzle. And we've only just started listening.